Welcome back. This is Ms. Killen here at MPB. I'm so glad you came back to learn with us here. We are in our Unit 6, those Introduction to Quadratics. We are continuing our Lesson 1, but now we are working with the quadratic. So let's look. We are looking at working with the quadratic function in real-world scenarios. We're looking at standards IF4 and CED3. I can recognize key features of a quadratic function and interpret key features of the quadratic function in real-world scenarios. So let's jump in and see what we've got. Still going to do a little review on those vocabulary. These vocabulary that we are coming across are very important. If we cannot speak the lingo, we're not going to be able to do the math. So we talked about the quadratic function, ax squared plus bx plus c. Talked about that the shape of a quadratic is called a parabola, which is this shape or this shape. We talked about the solutions and we talked about the zeros and roots as being where those parabolas cross or touch my x-axis. We talked about what those x-intercepts were, and we also looked at using our stat button on our calculator to put in that data so we can generate a quadratic function. So let's look. All right, so let's do some practice. Jake and Kedra are shooting a firework spaceship off the ground. They're calculating its height, then seeing how long it takes to get back to the ground. What type of function represents the data? How long does it take the spaceship to return to the ground? And approximately what is the highest it reaches? So let's say that it looks something similar to this. And then I have obviously 0, 1, okay, we have 0, 1, 2, 3, 4, and we have 5. We're going to put 4.5 there. And then we have 1, 2, 3, 4, 5, 6. Okay, so this is just an estimate of what it would look like. So then it says what type of function is represented the data. Well, obviously, we've got a quadratic. I mean, this is bar none quadratic. How long does it take the spaceship to return to the ground? Well, it starts over here is where they light it, and then it goes up and 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 up, and then about 5 seconds it's back to the ground. So I would say 5 seconds. Approximately what is the highest it reached? Well, this is my highest. So about 3 seconds it gets to 6 feet off the ground. So that is how I'm looking at these different parts of this quadratic to interpret them, to answer questions. If you can't understand what the different parts are representing, it's going to be hard to answer these questions. So we're having to look at the different parts, where it touched the x-axis, what the highest of the quadratic was, to answer these different things. So let's look at some more. Now, we're looking at the max of a parabola and the minimum of a parabola. It is called the vertex. These are our vertex. This is a big, big vocabulary word. Now, if I am looking at the max of a parabola, this is the maximum. Okay, when I talk about a maximum, it's going to be the top. Or we've also heard about maximum, the biggest. We've also heard when we talk about the maximum, the most. So when you look at the maximum of a parabola, you're going to have some type of top. You're also increasing as you go up the parabola to the vertex. And when you're coming back down from the vertex, you are decreasing, going down. Your y values are decreasing, so that means it's a decreasing part of the function. So now let's look at the minimum of a parabola. The minimum is usually the lowest, the smallest, or bottom. Okay, so right here would be my minimum. So what we're looking at is always read my graph from left to right. I'm decreasing, I'm decreasing, I'm decreasing, I'm decreasing till I get to my vertex. Then I start increasing. So that's how we're reading these different types of vertex, how I have to look at those parts of this vertex leading up to it or leading down to it and then going on its way after your turning point. The vertex could also be considered the turning point of that quadratic function. So we want to make sure that we're understanding these key words, these key phrases. Lisa jumps off the Pearl River Bridge after the rainstorm. The following graph represents the jump. So here's Lisa over here. Lovely little girl. Okay, so she is standing on the bridge and she jumps. What happens when you jump? You have to bend your knees and you jump out and then you fall, right? That's how you jump. So here is the graph of her jumping off this bridge. So then with this scenario in mind, let's see what it wants. It says, what type of function is represented by this data? Well, this is only part of the curve of the parabola, but it doesn't matter. It's still a parabola or a quadratic. So I'm going to go ahead and put my quadratic. All right, the next question is going to ask me, what is the approximate height of Lisa at 5 seconds? So after she jumps and the seconds are ticking by, we want to know at 5 seconds about how far along is Lisa. Well, if we look, Lisa is about what? About 25 feet off the water. So I'm going to put about 25 feet. Remember, we are always labeling our numbers. You always want to make sure that you're labeling your numbers. Then it says, how long does it take Lisa to splash down into the water? Well, we can see it's where my graph hits my x-axis, which is what? 9 seconds. Now, here's a new question that we've not been asked yet. Does this graph have a minimum or a maximum? Remember, minimum is the lowest or the bottom, maximum is the biggest or the highest. So I would say about right here would be my what? Yes, it's going to be, we're going to have a maximum. Good job, we're going to have a maximum. So make sure that all of those different components of that quadratic you see on this graph. All right, so now it's time for you to master. We're going to use this data below and our calculators to create a quadratic equation. Then we're going to look at Abby. She has a boutique in the mall. During her first year in business, she recorded data and created the following graph. The graph shows the relationship between her selling her duck-shaped boots and profit of the boots. You're wanting to circle the zeros of the quadratic function. You want to know what those zeros represent. You're going to put an X on the vertex. And then you need to know what that vertex represents in this scenario. So go ahead, pause the video. You and your table partner or you by yourself on your notes page, go ahead and work these problems. And then come back to me and I'm going to work them with you. Go ahead. All right, for my data, I'm going to plug this into my calculator. So go ahead and follow along with me or make sure that I put in like you did. So I'm putting in my calculator. Okay, so I go to Stat 1, and I'm going to put in my information 0, 1, 2, 3, 4, 5. I'm going to scroll right and put my Y information, -10, making sure I use the negative button, which is under the 3, not the subtraction. Enter. +10, 64, 152, 275, 430. I have all my information. hit that stat button again, scroll right to calculate, go down to number 5, press enter until I get to calculate, and there I have it. I got 16.98, so if we approximate, let's say 16.98, my B equaled 3.175, so let's go ahead and say that that is 3.18. And my C is negative 10.107, so let's say that that is a negative 10.11. So let's go ahead and write this. So I'm going to have 16.98x squared plus 3.18x minus 10.11. So there is my quadratic equation using the information that our calculator gave us. So now let's look at Abby's problem. Let's see what Abby's doing. Obviously, she has her boutique. In her first year of business, she's recording her data. She created the graph. Now we see the relationship between her selling prices of these duck boots and her profit. So first thing it asks us is to circle my zeros. So what I'm going to do is I'm going to circle my zeros. I'm going to circle them in purple. So here's 1 0. Here's another 0. What do my zeros represent? It is the place where I do not get any profit, because my profit is on my y-axis, and what is my y variable, or excuse me, what is my y value when it hits that x-axis? It's 0. So it means I do not get any profit. I do not have profit. All right, so now let's put an X on that vertex. So let's go ahead and put an X on the vertex. And I'm going to say it's about right there. And if I had to look, I would say it's about what, 30, 400. So then what does that mean? What is that vertex telling me? So when I am selling, or when Abby is selling these duck boots at $30, she's getting $400 in profit. So what we want to make sure is we understand what each one of these parts mean in this scenario. I want to thank you for coming to learn here with us at MPB today. We've had such a great time learning about these quadratics. I'm Miss Killen. Thank you and have a good day.